All right, so the first thing we're going to do then is we're going to take a look at the rest of 6.4. We stopped in the middle of it, and I believe we're on example 5. Does that look right to you guys? Okay. All right, so just as a reminder, let's actually look back at example 4, kind of to remind where we were. We're working in proportions, so anything that we're doing in this section is in proportions. What we're doing is we're doing a comparison. So whatever the problem is talking about, we have to figure out what they're comparing. In this problem, the comparison was being made between the way a map looked and what was really the shape or the size of, in this case, it was a park in real life. And then they were looking at the dimensions of the park, length versus width. So let's take a look at this one. This is Sheila and Dora, and they are working 3.5 and 4.5 hours respectively. That means Sheila worked 3.5, Dora worked 4.5, on a programming project. They were paid a total of $176 for the project. Okay? The question is, how much did each one earn if they were paid at the same rate? So probably most of you would look at this and you would say that Sheila should make less than Dora, right? She didn't work on it for as long. So what we're trying to do is we're trying to find out what would be the fair disbursement of the money so that they each get paid for the amount of time they worked. Make sense? Okay, so what are the things we're actually comparing? The hours and the money, right? How much did I work? How much did I get paid? Okay, so those are the two sides that I'm going to set up for my equation. So one side is going to be hours, and one side is going to be the money that they make. I guess I could have put time and money or something like that would have probably been better. We'll say time. Our time just happens to be in hours. Okay, so, and we're comparing two people as well, correct? We're comparing Sheila's situation versus Dora's situation. I'm going to put Sheila on top, just because she's first, and Dora on bottom. Now, the left-hand side of this situation here, this proportion, is the easier one, because you know that information. How much did Sheila work? 3.5. 3.5. And I'm going to put 3.5 just for what we're working with here. What about Dora? 4.5. If you want to work in fractions, that would be fine. The money situation is not as straightforward, though, right? In fact, that's actually what we're trying to find. We're trying to find how much each of them worked. How much each of them got paid for their work, right? So what do you think we should do? There's several things we could do. Let me say that.
If you found the total number of hours and then divided the money by the hours, then you would know how much they got paid per hour.
Okay, and I'm going to take a version of that, and I'm actually going to change what I just wrote. Okay, since that's the way you thought of it, and nobody else talked. Okay, so what we're going to do here instead is we're going to actually compare what Sheila made, Sheila's number of hours to the total number of hours. So Sheila worked 3.5 hours. What was the total number of hours that were worked between both young ladies? 8. Does that make sense? Again, this is not the only way. I'll show you the other way, the way to set it up, the way that I was headed before. I'll show you that in a minute, but let's go with this one. Okay, so if we do this, we actually know the total money that they made, don't we? Yeah, we do. We know that's 176. So the only thing we don't know is how much of that 176 belongs to Sheila. Does that make sense? This is a good way to do the problem. What would I do next?
Cross multiply.
Cross multiply. All right, so what is 3.5 times 176? Like this? Okay. And then I have 8 times x, so that's 8x. Now what?
8.
Divide by 8.
77.
So x is, what was that?
77.
77. Okay, now we solved the numerical problem that we set up, but we need to answer the question. The question said, how much did they each earn?
So she got 77. Now we can subtract.
So Sheila made 77, and we can subtract that 77 from the 176 for Dora, right? How much did Dora make?
4.5. Oh, sorry.
You could do it that way, or you can subtract and get 99, yeah. Either way you do it, you're going to get that Dora made $99. Okay, Let me show you another way of doing it, just because I want you to see that if we had continued along the path we were working before, there is another option. Remember we had the 3.5 hours and the 4.5 hours? So far so good? We could have still said that X is the amount that Sheila makes. Now think with me for a moment. When we actually found out that Sheila made $76, most of you found out Dora's amount by doing what? Subtracting. What did you subtract? The total amount, which was 176, minus what? Sheila's amount. In this case, it would have been X. So you could also set the problem up like this. This is not quite as pretty, is it? Because I actually am going to have to do some distribution when I do this cross multiplication of the 3.5 and the 176 minus X. You'll still get the same answer. It'll still work. You just have to approach it a little bit differently, and you can do that. Any questions on that one?
So like you would go 3.5 times 376 minus X?
Minus 3.5 times X. So when you do this piece right here, you'd actually have, what is 3.5 times 176? We already did that, didn't we? You'd have 616 minus the 3.5 times X. And on the other one, you'd have 4.5X. Because this 3.5 has to be multiplied by the 176 and by the X. Yeah, so you'd have to distribute.
Would it matter which one you did 176 minus
No.
X? Okay.
Yeah, you could just as easily have let Dora have the X down here and do the 176 minus X on top. That'd be fine. You just have to make sure that at the end you say which one did what. So you can't just say 77 and 99. You have to say who made what. So that's part of the identifying of your answer. Okay. Any other questions? Okay, let's take a look at one more. At Rattlesnake School, the teacher-student ratio is 1 to 30. If the school has 1,200 students, how many additional teachers must be hired to reduce the ratio to 1 to 20? So what are we comparing in the problem? Students to teachers or teachers to students, right. So since it said teachers, students, I'm going to put the teachers on top. I'm actually going to do the teachers on the top, and I'm going to do the students on bottom. And the reason I'm going to set it up that way is because they already gave me a ratio, the original ratio of teachers to students. So far, so good? Okay. They also told me something else. What else did they tell me? Close. How many students I have, right? They tell me I have 1,200 students. Now, this is not going to find my answer. What is it going to find? It's going to find how many teachers I have, which is really good and useful information because I need to know that, but it's not the answer I'm looking for. I just want to make sure everybody's clear on that. Once I'm done with this equation setup, I'm not done with the problem. So X here is going to be my number of teachers. And I realize that these don't match in terms of their units. They really do. I'm clarifying them as teachers and students, but what they really are is just people, right? Okay, so I'm just reminding you which is where. All right, so what am I going to get? What am I going to do next?
30x equals 1,200.
Okay, so I'm going to cross multiply, right, Brendan?
Yeah.
And I get 30x equals 1,200. And then divide by 30, and I have that x is 40 teachers. So what is 40 teachers telling us?
That's how many you have right now.
That's the now. Currently, I have 40 teachers. But my goal is something different, right? My goal is to have a 1 to 20 ratio. So how can I figure out how many teachers I want to have?
Do the same thing for 1/20.
Okay, so I can do the same thing for 1 over 20. And I still have 1,200 students, right? That didn't change. And let me use another letter here. Let me call this Y teachers, because I don't want you to think that the X's are meaning the same thing each time. X the first time is the teachers I have now. Y the second time is the teachers I want to have, number I want to have. All right, so cross multiply like we did last time, right? So this would be 20Y equals 1,200. Then what? Divide by 20. So what I want is I want 60 teachers. This is what I want. But the question asked me how many additional teachers must be hired. Right, 20. So I actually would need to hire 20 more teachers. So that's assuming that none of the teachers left and so forth, but we're assuming that they're here and they're staying. Okay. Any questions on that? Two-step process. You have to really think about what you're given and what you're really trying to find so that you don't stop too soon and give information that wasn't what you were asked for, right? Yeah. Okay. Let's take another one. Mary is working with measurements and writes the following proportion. 20 inches over 1 feet equals 5 feet over 60 inches. How would you help her? So what are some things that you would tell her about this? Let's talk first, because I know everybody always wants to talk about what they did wrong. What does she have correct here?
5 feet is 60.
Yeah. So her ratios themselves are correct, aren't they? So her ratios are right. That is 12 inches really equals 1 foot. Okay, so on the left-hand side here, that works. And 60 inches really does equal 5 feet. So her ratios are right. But Brendan, you already told me she's got a problem, right?
Yeah.
What's the problem? The units don't match up, right? Right now she's got inches over feet on the left and she's got feet over inches on the right. So her units are not matching up or lining up or something like that. They don't line up right. So what should she have? So there's 2 ways to fix it. Okay, actually there's more than 12 if you're going to, more than 12, more than 2 ways to fix it if we go that direction. Okay, try this again. Okay, so what could I do, Lauren?
Like put 12 over 60 and 1 over 5 equal to each other. So the inches are on the same side.
Okay, that's one way. What else could I do to fix it? Somebody give me another suggestion.
Have 60 inches over 5 feet.
Okay, and the other part stays the same. So like 12 inches over 1 feet or 1 foot equals 60 inches over 5 feet. So, and these are the 2 basic ways. Of course, we can flip either fraction upside down as it is. The issue is either that we want the inches on the left and the feet on the right, or feet on left, inches on right, or we want inches on top, feet on bottom, right? So when we talk about things lining up, we either mean that we want them to line up within the same fraction, in the same ratio, or along the same part of the fractions, either in the numerators or in the denominators. Make sense? And either one's fine, we just have to pick which one it is. What we can't do is we can't mix that notation. That is, we can't have feet in the top right corner and the bottom left corner. Sorry, this is what I did. Yeah, we can't do that, and that's exactly what she did, right? She mixed the notation up. All right.